What's up, interweb? Okay, today we're going to multiply and divide rational expressions. Now, what could be more fun than that? Okay, the first part of this we're going to multiply and write in lowest terms. So if we were to have 3/10 times 5/9. One way you can do this is 3 times 5. Remember, when you're multiplying fractions, you don't have to have a common denominator or any of that misery. You just straight across. That times that, that times that. Now, we're going to factor these things. You don't really have to do this, but it might let you show it a little bit better. What is 10? 2 times 5. What is 9? 3 times 3. Right? Right. So we can take out that 3 and either one of those 3's, and that 5 and that 5. So what are we left with? In the numerator, we have a 1, and in the denominator, 2 times 3 is 23. I know 6. Right? That's basically all there is to this. I think if you'll factor it out like that, it might make it easier at first. So what do we have if, what do we get if we have this? 6 over x times x squared over 12. Okay, let's factor each one of these things. 6 is 2 times 3 times x, right? X squared is x times x over x times 12 is 2 times 6. Okay, we could have left this as a 6 here. Let's do that. Okay, 6's cancel out. 6 divided by 6 is 1. And x. So what are we left with here? X in the numerator and 2 in the denominator. Okay. How about this? X plus y over 2x times x squared over x plus y all squared. Okay, so we have, now remember, the fraction bar kind of makes the numerator and denominator in parentheses. So we have x plus y times x, right? Right. And in the denominator, we have 2x times, now x plus y squared means x plus y times x plus y. Have to be in parentheses there. Okay, so x plus y cancel. 1x and x. So what do we have left? We have x in the numerator and 2 times x plus y in the denominator. Of course, you can multiply the 2 times both of these. It's going to be x over 2x plus 2y. There's no telling what they're going to, what form they're going to put this answer in on the final exam, but you probably will see one of these things on the final exam. Now, these problems, they really don't get any more difficult, they just get longer. Take a drink of your Diet Coke. X squared minus 3x minus 4 times x squared minus 5x plus 4 over x squared plus 2x minus 3. Okay, we're going to have to obviously we're going to have to factor all this misery here. Okay, so what can we factor out of this? X open, x plus 3 closed over. Now, what are the factors of negative 4 that add up to this? It's going to be what is that? X minus 4 and x plus 1. Is that right? Negative 4 times 1 is negative 4. That's right. Negative 4 plus 1 is negative 3. So that's right. There's no need of writing this under two radical or two what do you call it? Fraction bars. So when we factor this, we get remember, this is negative. The linear term's negative. The constant's positive, so we're going to have x minus something and x minus something. What are the factors of 4 that add up to negative 5? It's going to be negative 4 and negative 1. Negative 4 times negative 1 is positive 4. Negative 4 plus a negative 1 is negative 5. So we're right. Now we factor this one, and we get, let's see, linear term's positive. The the constant is negative, so we're going to get x plus something, not 1, and x minus something. Okay, what are the factors of negative 3 that add up to this? Is going to be x plus 3, sorry, not 1, and x minus 1. Is that right? I think so. Okay, now let's look, what can we reduce? Here's x minus 4 here and x minus 4 there. So we can take those out. X plus 1, no. X plus 3, yes. Here and here. X minus 1 here and here. So what are we left with? All the numerators gone except for x. And what's left in the denominator? X plus 1. See, it's really not difficult. It's just a long, drawn-out process. Now you can see why we spent so much time factoring, because it comes into play in an awful lot of these things here. Hold on just a second. Okay, how do we divide fractions? You don't. You multiply by the reciprocal. What's the reciprocal mean? Flip it over. Only this one. So we have 7/8 times, okay, you do not divide fractions. You multiply by the reciprocal of this number, the second number. And the reciprocal means flip it over. Right? Right. Now what you can do is you can go ahead and we can put it under one fraction bar. 8 times 1, which is just 1. Now if you want to, you can go ahead and reduce this. Don't have to, but makes the numbers a little easier. 4 and 8 divided by 4 is 2, I think. This is 1. So we have 7/2. And that's all there is to it, which is like that. Okay, basically the same stupid thing when you have okay, what if we have this? Three x all squared over 2a cubed divided by 6x cubed over 16a squared. Okay, now these are not in parentheses, so the exponent only goes to the base number, not to the whole thing. However, this one, okay, so how do we divide fractions? We don't. We multiply by the reciprocal. So let's go ahead and expand this. 3x all squared means 3x times 3x. Let's put it in parentheses to maybe help us out a little bit. Over 2a times 2a times 2a. Okay, because it's cubed. Times 16a squared, right? We're gonna multiply by the reciprocal over 6x cubed. Okay. Now let's expand this a little bit. We have okay, 3 times 3 is 9. X times x. This one is 16 times a times a. This one is 2 times a times 2 times a times 2 times a. And what do we have here? 6x cubed is 6x times x times x. You can do it like this if you want, or you don't have to. First of all, let's see if we can do something with this 2. 2 and 16. That's going to make that 8, right? Here's a. There's an a. There's another a. And that's all. Now, we have 2 and 2 is 4, right? 2 times 2 is 4. So we can cross that one out, make that into a 2, right? And let's see. Did we take care of all the a's? No. And 6 and 9, we can factor both of those by 3. It's 2 and 3. Everybody with me here? And 2 x's and 2 x's. Oh, that 2 and that 2 can cancel. So what are we left with in the numerator? Looks like only 3. And what do we have in the denominator? An a and an x. This a and that x did not get canceled out. Okay, these aren't particularly difficult. They're just kind of long. Take your time with this, so it's easy to get fouled up with it. Okay, page 2. Okay, what if we have this? Get this if you're so smart. X squared minus 4 over x plus 3 times x minus 2. I'm surprised they didn't make you factor that, but who knows what goes through their godless brains. And we have x plus 2 times x plus 3 over negative 2x. Now again, how do we divide fractions? We don't. Now what is this? You need to look for these because they come into play a lot. What is it? Right, it's a conjugate. So x minus 4 all squared is x plus 2 times x minus 2. Right? Right. Over x plus 3 times x minus 2. You can see we're going to be able to reduce those. Times a negative 2x. And then our x plus 2 and x plus 3 go down there. Okay, we're multiplying by the reciprocal. Well, I tell you, if this doesn't make your head throb, nothing will. Okay, x minus 2 and x minus 2, those cancel. X plus 2, and here's an x plus 2. We can do that. And looks like that's it, huh? Is there anything else we can do? I don't think so. So we have negative 2x in the numerator, and x plus 3 times x plus 3. You can write it like this, x plus 3 all squared. Okay? Same thing. Right? Right. Okay, as you can see, these really don't get any more difficult. They just get longer. Mm-hmm. Mm-hmm. Now look, automatically you should see the difference of two squares is a conjugate. Now don't forget, what is 1 squared? 1. So this is a conjugate also. Divided by 2a squared plus 4a over 1 minus a. 1 minus a. Uh-huh. Okay. Let me see if I can squeeze everything in over here. Let's go ahead and factor this conjugate here. It's going to be a plus 2 times a minus 2 over. And this is a conjugate also. A plus 1, because both of these are perfect squares. And it's the difference of, so this is a conjugate, a minus 1 times, okay, 1 minus a. What we can do to get rid of this negative a is we can multiply by negative 1, and then we get a minus 1 over. Now, what can we factor out all this misery here? Looks like 2a, huh? 2a, times a plus 2. Is that right? 2a times a, 2a squared. 2a times 2, 4a. So we're right. Okay, now what can we cancel out immediately? A plus 2, a plus 2. A minus 1, a minus 1. Anything else? Doesn't look like it. Mm-hmm. Mm-hmm. So what do we have here? this equals a minus 2 times negative 1. Okay, don't forget about that. Over 2a times a plus 1. And if we multiply this negative 1 out here, you're going to get negative a plus 2. Okay, all that happens there is the signs change. And you get, of course, you can multiply this out. I don't know what they're going to do as far as the answer on the final, but it'll be something like that. Okay? What could be more fun? Okay. Now this is when you have complex fractions and you're adding them. There's several different ways you can do this. I think you'll find that this is the easiest way. 2/3. Now we're not multiplying and dividing anymore. Now we're adding. 5/9. Now we have to have a common denominator. When you're adding or subtracting fractions, you have to have a common denominator. I think you'll find this is the easiest way to do this. At first, it's going to seem pretty confusing, but it's really not. Get your drink your Diet Coke. The first thing I'm going to do is cross multiply. 9 times 2 plus, okay, plus 3 times 5 over, and then you multiply the denominators. 3 times 9. Okay? Now look, remember, if you have, now there's a separate rule for fractions. Can we take the 9 out of here? No. It has to come out of both of them, not just one. So if you have x plus 4 divided by 2, can we reduce this? No. It has to come out of both. This would be equal to, well, let's see, let's just leave it like that. Now, how about if we have this? 4a plus 6 over 2. Now, can we reduce this? Remember, it has to come out of both of these terms, not just one. So this is equal to 2a plus 3. Divide 2 by, it's kind of like the distributive property for division. When you have, remember this is in parentheses, so we can divide each one of these terms by 2 and we get that. Now we have the same thing going on here. We have 9 times 2, which is 18, plus 15 over 27. We can do that, which is, where are we? Which is equal to, what is it equal to? 43. No, 33. 33 over 27. Can we reduce this? Yes. We have, both of these are divisible by 3, so we have 11 over 9. Right? Right. Okay. This is good stuff, huh? And you don't have to, there's no extra charge for this. Take your drink your Diet Coke. What about this? Get this if you're so damn smart. Six plus 3 over x. Now 6, remember, is actually 6 over 1. We just don't write it because we're lazy. So what do we have? 6 over 1 plus 3 over x. Procedure's the same. Cross multiply, and we get 6x plus 3 over, and then we multiply the denominators. That'll give us a common denominator. Okay, cross multiply. Don't forget about the sign here also. So is there anything we can we reduce the x's? No. Is there anything else we can do here? No. So all there is to it. Okay. Now this is where they get really kind of nasty. Why y'all looking at me when I say nasty? 6x plus 3 over x all over, remember the fraction bar means divided by, 2x plus 1 divided by, excuse me, 8. So this equals 6x plus 3 over x divided by 2x plus 1 over 8. And how do we divide fractions? We don't. We multiply by the reciprocal of the divisor. The divisor is the second number. So we get 6x plus 3 over x times 8 over 2x plus 1. Now, what can we do here? We can reduce this. We can factor this, the numerator here, into 3 times 2x plus 1, right? Times 8 over x times 2x plus 1 closed. Now what can we do here? We can do the 2x plus 1, 2x plus 1, so we get 3 times 8 is 24 over x. Is that right? I think so. Okay. That wasn't too terribly bad now, was it? All right, what do we get here? 1/4. Last one, I promise. Minus 1 over a squared, all divided by 1/2 plus 1 over a. Okay. Excuse me. So we have 1/4. Oh, we're going to have to cross multiply here, because we have to add these things together. A squared times 1 is a squared. 4 times a -1 is -4. What do we have here? Nice, pretty conjugate. Over, again, cross multiply, and we get a plus 2. Okay, cross multiply. Oh, can you be more stupid, bonehead? Okay, we got cross multiply. I forgot to multiply the denominators. Okay, so we get a squared minus 4 over Remember, we got the minus because of this. And then a squared, or 4a squared, I'm sorry, divided by, cross multiply, we get a plus 2 over 2a. And how do we divide fractions? We don't. So we get, look, a squared minus 4 is a conjugate, so we get a plus 2, a minus 2 over 4 a squared. Let's see, is that right? Yeah. Times 2a over a plus 2. Okay, now we can factor this into 2 times 2 times a, right? Right. Okay, a plus 2, a plus 2. 2a, let's take 2 and 2, a and a. So what do we have left? A minus 2 in the numerator and 2a in the denominator. Now can we reduce the 2, these two? No. Can we reduce the a and the a? No. Remember, they have to come out of both terms, not just one. Is there anything else we can do there? No. That's all. Bye-bye. Bye, bonds.